Good morning students. In the previous class I have told you about RC circuit, how it grows. Now in today's class let us discuss about growth and decay of RC circuit. Okay. So in this, what is R? R is resistor. C is capacitor. Here, what is a circuit? Here, the circuit you can see here. This is R, this is C, capacitor. There is one key attached to that. And you can also tell it as a switch. This is R, this is C. And here we will be connecting a battery which is called as E. Okay. So in this, the switch can be on or off. In the previous class I said you about RL circuit, how it is increasing. But in today's class we are using a circuit which is consisting of capacitor, which is also called as condenser, and this is resistor. So here once you see I am writing this terminal as B and this is A. When the key is here, when the key is connected from A to B, here you see switch. If I get connected to these two terminals, what happens is the charging of condenser takes place. What happens? Current from this element, the bigger one is positive terminal, the smaller one is a negative terminal. Okay. So in this, if you observe, okay. So in this circuit, what are the elements we have taken here? R is a resistor, C is capacitor, S is a switch, E is a battery which is connected. For the battery, what terminal is being connected? You see here, plus is a positive terminal, minus is a negative terminal. So current flows in this direction. Okay. So now in this process, a charging of capacitor is being held and try to induce more and more charge on the plate of the condenser. Here you see, when the battery is on, power supply is going like this and this capacitor will be charged up. Here it stores the energy. It stores the energy. Is it so here? Power supply is going like this and this will be charged. Here in this process, what is the capacitor doing? How current is being increased is the next step. Okay. So let us discuss about that. What is E? E is battery. When battery is on, what happens? Capacitor gets charged up. And what it will store? It will store energy. That energy, how it is stored? By charge particles. Charge particles. So because this is a cyclic chain. Got it? So in this process, here how many charge particles are there? Q is charge. So when current is flowing in the circuit, what is circulating? Charges are moving. So because of these charges, what is produced is the next step. What is that in the next step? EMF, that is electromotive force is developed. and a back EMF is developed in the circuit, which is decreasing the rate of charge of condenser. This leads to the consideration of rate of growth in the circuit. So what is the second part? When battery is on, the capacitor gets charged up. The energy which is floating from the battery E creates particles to move, and those particles get charged, so that is why it is called as charge particles. And here the charge particle is denoted with key Q, which is in turn giving a developing of back EMF, which leads to growth of charge. Right? So now let us discuss in this process what is the equation which is specifying by the circuit. E is equal E by Q by C. E minus Q by C is equal to R into I. In this process, Q is charged, okay, across the condenser, and Q by C, whatever term, the second term you have taken here, Q by C is a back EMF, okay, or else potential difference you can write, potential difference. Then one more point, E minus QF, this E minus Q by C is here EMF, which is equal to R into I, that is where R is a resistance, and here I is equal to small current, that is I is equal to dq by dt. Clear? Now we will substitute the values here. I is equal to dq by dt in the next equation. So before that, please take this first equation. What is that first equation? E minus Q by C is equal to R into I. Is the first equation. Now you substitute I is equal to dq by dt in the above equation. What you will get? E minus Q by C is equal to R into dq by dt. Right? Now suppose if I assume that E is equal to Q naught by C. Okay? If I assume that E is equal to Q naught by C and substitute in this equation, what I will get? This is equation 1, 2 and this is 3. Now substituting this 3 in 2. What we get here, you see? E means Q naught by C minus Q by C is equal to R into dq by dt. This becomes equation 4. Please write that. Then I am arranging this. So in the previous equation, if I take common C, Q by C is equal to R into dq by dt we got, right? Now what I am doing is dt to this side. dt into Q naught minus Q by, okay? What I am doing is sending this dt to this side dt, okay? by r to this side. Cr is equal to dq by q naught minus q. That means I am making all q elements to one side. Now the next step is integrating. Integrating these two terms on both sides. What I get? Integral dt by Cr is equal to dq by q minus q. Okay? So integration of dt becomes what? Integration of dt becomes t, and Cr is constant. Cr is equal to integration of dq becomes q. Okay, what formula we are having here? Integral dq by q means you can write this in the form of log of q naught minus q plus some constant a. Here if we see, this is the formula of dq by, or else you can also write dx by x, means you will write log x na, like that, log x. So that we have applied there. So x means what we are having here? Q naught minus q na. So I am applying this formula and I have written this. So please take this calculation. Now for this we will be taking the time constant. What equation till now I got? T by Cr is equal to minus log E q naught minus q plus A. Now if I take T is equal to constant, Q is equal to 0, that means when T is equal to 0, that means when there is no electric field, there will be no charges. So this factor becomes what? 0. Is equal to minus log E q naught plus A. So again A to this side I will write A is equal to minus log E q naught. So now what value I have taken? I took the value of A. Now substituting that value in this, what I get? I am erasing only these boundary conditions, you see. So what I get above equation? T by Cr is equal to minus log E q naught minus q. This A value is what? It is plus A, no? That is plus log E q naught. Now it is in the form of log A minus log B. Now I will take minus common, you see. Minus T by Cr is equal to log E q naught minus q. Minus I have taken common, so here you get log E q naught. Now it is in the form of what? Log A minus log B. Or is log A minus log E means what can we write? Log A by B we can write what? So log E q naught minus q by log A q naught. Okay, please take that calculation. Even in unified physics in page number 250 you have this topic, you can refer that. I will be giving the notes. Next one. So now you got the term will write it once again. Minus T by CR is equal to log E Q naught minus Q by Q. Now if I want to change this value to exponential, okay, if I want to send to this side, what the other term it goes is exponential minus T by CR is equal to Q naught minus Q by Q. So what happens to this value Q naught by Q naught? Here Q naught, sorry. So Q naught by Q naught minus Q by Q naught you get. The next step. This becomes what equal to 1 minus Q by Q naught. A little bit mathematical words are represented here. Calculation. So what you got there? Exponential values. No? In the next step. What I am doing here? This one I will send to this side. Or else this to that side. What happens? Exponential of minus T by C R is equal to what? 1 minus Q by Q naught. Is it? Now what I do is this I will send to this side and this term to this side. So what I get? Q by Q naught. Is it so? Q by Q naught is equal to 1 minus exponential of minus C by CR. Now if I want to know the value of only Q, this will go to that side. So it becomes Q naught into 1 minus exponential of minus T by CR. Right? In the another word, how can you write 1 minus exponential of e power also? I can write. Okay? So finally we have got the values of Q is equal to Q naught 1 minus exponential of T minus C by R. Okay? So this is the value of Q. So finally what we have done here, taking R and C circuit, by giving electric field, what is happening? Charging is carried out. C is being charged. Because of that, how many number of charges are being developed? Because of electromotive force is being carried out. Okay? So in this process, what is the expression is, what we have got, Q is equal to Q naught 1 minus exponential, I am writing it as e power minus T by CR. E minus, this is a expression. Okay. So next we will see the graph. What type of graph we get as time is increasing. Now as time is changing, okay, as time is changing, what is a Q? That means how many number of charges? Is it decay of RC, means charges are decreasing, or charges are growing? in RC circuit is our target. Okay. So what is the graph which is specifying this is, you see here, T Q. And here you see the graph like this. It is increasing now, so it is growth of charge. And this peak values is called as Q naught. This is a time function. So as time is increasing, you get the charge carriers like that, and after it reaches the particular storage equal to the EMF, you get a graph like that. So this is what called as growth of current. Then what is the value which we get for growth of current? How do we calculate it? Is there is one formula for that. I will show you that. That is given by Q is equal to 0.63 into Q naught. This is the formula which we use for growth of RC circuit. Okay. Then the next formula, that means from this 0.63 Q naught, what you understand here is the charging is 63% of maximum of charge C, and this is called as time constant, which we will be doing in our practical. So this is what we have discussed about growth of current. Then what is decay of current? Decay of capacitance. For decay of current also, what we do is, we will not connect plug. Suddenly you will off the switch. What happens till then? Whatever it is increasing, it starts decreasing in the reverse process like this. As Q, and this is, it starts, time starts, you will get graph in a reverse. So that is, this is growth na. Decrease means like this. Decay of current, and its time constant here is given by how it is decreasing. Not suddenly it is decreasing to 0. It is decreasing to the level of 0.37%. That is, Q is equal to, you get 0.37 Q naught. Okay. Q is equal to charge, and graph is like this. You get like this, Q T. So similarly you can do RC circuit, RL circuits like this only, where you will be having experiment also. In this you will be taking growth in charge in LCR circuit. If I take LCR, how it will be, those all things you can do practically. So from this I have given you some internal questions. How will be the density of charges in growth of current, whether it will be increasing or it is decreasing? And one more thing, what is decay of current? How much of percentage is there for decay of current? Okay. And here, what is time constant? How it is calculated? Time constant is a product of rod, resistor and capacitor C. Right? Now we have learned here theoretically how the circuit will be, how it will be calculated and how time will be calculated. This in the next video you will be learning about what is RC time constant practically. So what in today's class we have discussed is about what is RC circuit, what does it consist of. It consists of resistor, capacitor, battery and a switch which acts like on and off for the flowing of circuit, for the flowing of electrons. And when switch is on, the condenser is charged up. Then simply to tell, charged particles moves from the condenser and they will be stored there. How many charged particles are there is our own interest. Here to calculate Q naught is equal to, Q is equal to Q naught into 1 minus exponential minus T by RC. Similarly, what is the percentage of calculation of growth? That is 63% of charges, right? The next one here is about what is decay of current. So how decay of current is there? How decay of current is being calculated? When the switch is removed, that means A and B, as I have shown in the circuit. Charging means here R, C. If I keep switch S on, it becomes RC, growth. Off means decay. So for this, how much of time is taken by the capacitor to get charged up? Okay. If you know the value of R, C and time, you can also calculate the value of charges theoretically. Okay students, this we will be doing practically in tomorrow's class. If any doubts regarding this, you can ask me through WhatsApp. And furtherly, I have told you to submit the assignments. Please submit the assignments in the group at least by WhatsApp, and when you come to college, you please give me that assignment. Okay, so see you in the next class.